All right, in your instruction book on page 42, this one is talking about multiplying numbers in scientific notation. Read the problem below and then explore how to multiply numbers expressed in scientific notation. Now, I gave you some tips yesterday for anything math related. The first tip I gave you was to always look at your operation. When I look in the middle of this problem, I see multiplication, so I know I'm multiplying these numbers. The second tip I gave you is if you want to work with numbers, you need to put them in the same form. Now, there is nothing wrong with putting both of these numbers in standard form, multiplying them, and then converting to scientific notation, as long as you put your answer in the correct format. Now, if you're going to have to put it in scientific notation anyway, my advice is convert this and then follow the steps because multiplication is easy anyway. Now, 0.0804 is not in scientific notation because it does not have a base 10. We need to move the decimal so that the number is between 1 and 9. If we move it between the 8 and the 0, it becomes 8.04. So we'll rewrite our new constant at 8.04, and we're going to give it a base 10 so that it's in scientific notation. Now, the base 10 represents the number of place values that we need to move that decimal. I'm going from 0.08, I'm going over 2 decimal places to make it 8. And since my initial number was less than 1, my exponent is negative. So it is a -2 exponent. So I've got 5.78 times 10 to the 5th times 8.04 times 10 to the -2. Now they're going to talk to you a little bit about estimating what the answer should be like so that you can compare at the end. It's used as a check method, and that's what they're telling you here. Now, I'm ignoring their work right there just because I'm going to show you how I estimated it. My estimation, I would want it in scientific notation before I estimate. That way they're both in the same format. I've got 5.78. If I wanted to round that to a whole number because I know how to multiply whole numbers, I would round that to 6. I would call it 6 times, and then 0.08, we change that to 8.04. I'm going to round it to 8. 6 times 8 would give me 48. And then, of course, we would have to combine those base 10s. So we would still have to work with the base 10s, but we should be ended up with a 48. Let's see, the product rule, 10 to the 5th and 10 to the -2 makes 10 to the 3rd. It's not in correct scientific notation, but it does give me a starting point for where I should be. Okay, I'm looking at 48 times 10 to the 3rd or 4.8 times 10 to the 4th if I was to fix it. Now, just set that thought aside. We'll come back to it. They are showing you their method for converting from standard form to scientific notation. I prefer my method. You can use whichever one works best for you. Okay, if their method is your best friend, please use it. Okay, I'm not saying my way is the best way. That's just how I do it. So either way is fine. I'm not going to go through it, though. You can do that on your own. Now, the point of all of that was to get us down here where our new problem is both numbers are in scientific notation and we are ready to multiply. Number 9 at the top of the next page says complete the equation by applying the associative property to group the decimals and to group the powers of 10. So they want us to rearrange this problem. They want the constants being multiplied together. So 5.78 times 8.04. And then they want us to group the base 10s together. And the base 10s are 10 to the 5th and 10 to the -2. We're grouping the like terms. Now, number 10 says multiply the decimals and multiply the powers of 10. So we're going to take 5.78 times 8.04. Now, we've already said that 6 times 8 is 48, so we're looking for a number that is close to 48. When I multiply it out, I've got 5.78 times 8.04, and I get 46.47. Is that approximately 48? I'm pretty close, right? That tells me that I'm looking at an answer that's probably pretty reasonable. I do need to check the base 10s, though, because we want to make sure we're not off by a factor of 10. 10 to the 5th times 10 squared, you're going to use the product rule. And the product rule says that we keep the base 10 and we add the exponents. So 5 plus -2 makes 3. Number 11 says to apply the properties of exponents to write your solution in scientific notation. This is not correct scientific notation because our constant is too big. Now, I need to decrease my constant by 1 place value. Okay, if I decrease the constant by 1 place value, I increase the exponent by 1 place value. So I would have 4.647 times 10 to the 4th. Number 12. Look at the estimated on the previous page. Is your solution reasonable? Now, our estimate was 48 times 10 to the 3rd. If I fix this as well, okay, I can't compare these because they're different. If I fix it, I have 4.8 times 10 to the 4th. 4.6 and 4.8. Yes, it is reasonable. Okay, our approximation is reasonable. Guys, I could hit that with a hand grenade. It's hand grenade close. We're good enough. It just says, I'm checking my work. Do I think my answer is correct based on those approximated values? And yes, they are. Now, is that close enough for science? No. Okay, is it close enough to be right in math class? No. Okay, approximations are just that. They're an estimation. This is the exact answer. Okay, that's the correct answer. We're just using the approximation as a tool. Number 13. Why is it necessary to make the exponents the same? Why is it unnecessary to make the exponents the same before multiplying the numbers expressed in scientific notation? Now, easy explanation for this, because we combine the base 10s as well. If you remember, in addition and subtraction, I told you combine the constants and keep the base 10. When we're multiplying and dividing, we have to combine the constants and we have to combine the base 10s. That's why they don't have to match, because we're going to combine them at the end. At the bottom of the page, number 14 and 15 are examples. Number 14 says that the world's thinnest computer chip is 7.5 times 10 to the -3 millimeters thick. What would be the height of a stack of 3 times 10 to the 9 chips? Now, they're giving you a thickness, and then they're giving you a number of chips that they're going to stack up. It would be just like sheets of paper. If I had 13 sheets of paper that was 1 millimeter thick, and I stacked those up, we would multiply the thickness times the number of the sheets of paper, right? That's what we're doing here. We're going to take the thickness of the computer chip, and we're going to multiply it by how many are in that stack, and that's going to tell us how tall the stack is. So when I set it up, I've got 7.5 times 10 to the -3 times 3 times 10 to the 9. Because it is multiplication, and you can see that it's multiplication, I am going to multiply the constants. 7.5 times 3 makes 22.5. Then I'm going to multiply the base 10s using the product rule. And the product rule says that we keep the base 10, we add negative 3 plus 9. We're going to add those exponents to get 6. So the height of the stack will be 22.5 times 10 to the 6th millimeters. The last step is to always verify that the scientific notation is correct. My number, my constant, is 22. Is it okay for it to be that big? No, it is not. It has to be less than that. It needs to be 1 digit. We have 2 digits. So I need to move my decimal. I need to make 22 one place value smaller. Okay, that is a decrease. So I'm going to decrease my place value by 1. And if I decrease the place value, I increase the exponent, giving me 2.25 times 10 to the 7th millimeters. 15 says the speed of a garden snail is about 8.3 times 10 to the negative 6 miles per second. If a garden snail moves at this speed in a straight line for 3.6 times 10 to the 3 seconds, how far would the snail travel? Now, I'm pretty sure in science class, you're going to have to know the distance formula. Distance is equal to rate times time. This is a distance problem. This is multiplication. If we multiply the rate, which is in miles per second, times the time, which is the number of seconds, it's going to tell us how far that snail will travel. So the rate, 8.3 times 10 to the negative 6 times the time, which is 3.6 times 10 to the 3 seconds. That's going to tell us the distance. The operation is multiplication. I know this because there is a multiplication in between my two groups of numbers. I'm going to multiply my two constants together. 8.3 times 3.6. If I rounded, I would have roughly 8 times 4. It's what, 32? So I should get somewhere around 32. I'm going to use my calculator because I don't know what it is off the top of my head. I would if my calculator would work. 8.3 times 3.6 is 29.88. I'm a little bit off from 32, but I'm in the ballpark. Okay, I know that I'm on the right track. Then I'm going to combine my base 10s using the product rule. Negative 6 plus 3 is negative 3. I am not in correct scientific form. I need to shift my decimal place and make my constant 1 decimal place smaller. If I am decreasing the decimal, I am increasing the exponent to give me 2.988 times 10 to the negative 2. And that is my answer.